fun one for me. I love graphing. So this problem says to graph the, or asks us to graph the inequality, and this is a two-dimensional linear inequality. So even though there's only one variable, this is a two-dimensional problem. So I've drawn some coordinate axes here to help us out. Okay, for the first one, it says to graph y is less than 3. So y, I'm going to move up the y-axis 1, 2, 3 units. And if y were to be equal to 3, I know it does say less than, but if y were to be equal to 3, that would be the horizontal line that goes through y equals 3. So I'm going to draw in a horizontal line going through y equals 3, as close as I can anyway. Looks like I missed it a little bit. But I'm drawing it dotted because I want to be up to and not quite including the number 3. Okay, so I'm going to look like that. Now, I like to plot an extra point here. I'm going to call that 0, 0. And I'm going to imagine what would happen if I were to try to plug in the x equals 0, y equals 0 from this red point into the given inequality. So if I were to substitute this into the original inequality, notice there's no x coordinate. So I would really just be saying 0 less than 3. And notice that that is a true statement, and therefore the shading is going to include that red special point. So the shading is the whole bottom half of the plane. It's all the things that are less than 3 from the y-coordinate perspective. Okay, and this one deserves an extra problem. Let's see if we can do an extra problem here with a different version, a different direction. X bigger than or equal to 2. So now we're on the x-axis. So I'm going to go out to x is 2, which is located right there. And then I'm going to draw in the line x equals 2. Again, I know that it's not equals to 2. It's bigger than or equals to 2. But I'm going to take x equals 2 as the border. So I'm going to come over here to the x equals 2 and draw in a line. And this time it's going to be a solid line because it says bigger than or equal to. So dashed line for less than, up to but not quite including, or bigger than. And if it's potentially equal to, we'll use a solid line. Now again, generally my process, because it's abstractable to other problems, is to consider the point 0, 0, which is located at the origin. So if we were to substitute in the x coordinate of 0, we would say 0 bigger than or equal to 2, and that's false. So we don't want to shade the side where 0, 0 is. Instead, we will shade the other side, and that's the answer to this inequality. Okay, so let me move to the next screen and let you try one on your own. See if you can do the problem y less than or equal to 1. Okay, assuming you gave it a shot here, pause the video and tried it on your own. To follow our same process. Y, so we're on the y-axis, up 1 point, up to there. Now, since it's y less than or equal to 1, we're going to pretend it were equals to 1 and draw in that line as a border. So we're going to go to that y-coordinate of 1 and draw in the horizontal line that's located at y equals 1. Notice it's solid because it's less than or equal to, potentially equal to. Next, test the point located at the origin, 0, 0. The y-coordinate is 0, so consider 0 less than or equal to 1. Is that true or false? Well, 0 is certainly less than or equal to 1, so this is a true point, so therefore we want to shade the side where 0, 0 is. So in this case we shade below the blue line, and that's the final answer to this inequality.